Hi friends, welcome to today's class. We want to look at the topic in physics, energy quantization. And I've drawn this to enhance comprehension. Now, we're using a monatomic element or atom called hydrogen. It has one electron and one proton. Now, generally, an atom would have a nucleus where the protons and neutrons are located, because the mass of the nucleus is mass of the proton plus mass of neutron. Now the electrons are orbiting the nucleus because there is an interaction, electromagnetic interaction between the nucleus and the electron. The nucleus is positively charged. It's positively because nucleus is proton plus neutron, and proton is 1 proton. Neutron is 1 0 neutron. It has no charge. It has no charge. So if you add the charge of the proton to the charge of the neutron, what you get is 1 plus 1. Talking about the charge, you're adding the two charges. What you get is plus 1. That is the reason the nucleus is positively charged, and so it is interacting with the electron. There is, and of course, the field will emanate from the positive side and end at the negative side. So they are electromagnetically linked and interacting. Now, when we say the energy is quantized, it means the energy of an electron of an atom occurs in definite amount, discrete quantity, definite amount. What it means is that, the electron is orbiting this nucleus. Now, because the energy is quantized, you do not have this electron. This is the ground state energy, which corresponds to, these are all concentric circles, but we just have drawn them as horizontal lines for easy understanding. Now, this is the ground state energy level, where n is the electron quantum number. So this is quick correspond to the first shell there. Now, when we say the energy is quantized, it means it occurs in definite amount. It occurs where n1 is n equals 1, and where again you find energy is where n equals 2, where it has an energy is n equals 3, and on and on. You don't have in between. There can be no in between or below. If there is an energy, if it is continuous, like you would have in macrophysics, like if a car is moving, the energy of the car is continuous. For instance, if the car has a velocity of 3, its kinetic energy is half mv squared. It will have a certain energy. If it is 4, 3.5, whatever velocity it has, it will have, the energy is continuous, but not with atomic particles. They are quantized. So if you give the electron a certain energy of excitation, if the energy is not enough, it will not leave the ground state. It will not leave the ground state. It will remain where it is. It will not leave the ground state. It will remain where it is. Now, if it's enough, it can jump. Now, what the quantized nature of its energy is the reason the electron does not spiral into the nucleus and disappears. Look at this. The electron is, this is the nucleus, and the electron is moving. Electron is moving. So it has a certain velocity v. Okay? So the velocity is changing at this point. Look at the velocity. At the other point, look at the velocity. At this other point, look at the velocity. So change in velocity with time is acceleration. So the electron and atom is accelerating. A car, ordinary car moving on the road, requires energy to accelerate. So if it were not quantized, if it could assume any kind of energy, what it means is that at a point it will assume energies less than ground state energy, making it will lose energy to accelerate, and so it might spiral into the nucleus, and that will spell doom for all particles on the earth, because we all house atoms, and because of this, we are who we are. Thank you very much. I hope this helps. In our next class, we'll talk about excitation energy. Then we'll talk about excitation potential. Thank you very much. God bless you.